Welcome, everybody. We're going to be working on the remainder of exercise 6.4 from chapter 6. If you recall, we had started by building a list, and we just made a really simple one with the numbers 1 through 10 inside of it, right? And the list is denoted in Python by using square brackets. Often in other languages, we call the structure an array. There are some differences, though, and not to confuse things, but also in other languages, arrays also have other formats called lists as well. So it gets a little bit convoluted. But in Python, this is a list. If you change the containing punctuation to parentheses, it becomes a tuple. And a tuple is just like a list, except it's immutable. It can't change, right? And this is a multi-part exercise where we're doing a number of different tasks over these couple ranges of numbers here. And we had done the first piece, which was to swap the first and last things in the list and move them around and basically rebuild the list. So I'm just going to run this so you can see what it does, right? So there's the original list. We swap the first and the last elements. And you can see 10 is where 1 was and 1 is where 10 was, so it is working. We're going to move on to the second part of this. And the instructions for the second part are this, and I'm just copying them from my other screen. So I'm going to be adding this to the main program body here. And I don't want to do it here. I want to do it after all this stuff. And the next part of the exercise is this, and it says shift all the elements by 1 to the right and move the last element into the first position. Now, this is kind of like doing like a shuffle in the line. Like if you can imagine, like maybe you guys are in gym class or something, and your teacher or coach or whatever tells you to like line up from tallest to shortest or something, and then takes the last person, moves them to the first spot for whatever reason, and then tells everybody to take one step to the left or something like that, right? That's basically what we're doing. So if you think about the maneuvering that has to happen here, we're going to do that by shifting everything in the list. It's not like a really small ask. It's like every element has to be moved. And we have to come up with like a strategy that works. And believe it or not, it's very doable. So if you remember how we did this one, the first one, the way that we accomplished it, right? If you're going to move 1 to the other position, you can do the initial maneuver directly. So for example, I can move 10 over to the 1 spot, but then I lose 1, right? What happened to 1, right? If I don't put it somewhere, I lose that piece of information. So what we did is we pulled it out of the first position, stored it in a temporary variable, then took in that first position and put the last item. And then we took the first number out of the temporary position and put it into the first position, right? So it's kind of like a little shuffle, but we needed a temporary storage spot to make it happen, right? We still need to do that here, because if you're going to basically do the same thing, so if I like pull one of these out and then shift all the rest of them over, then I have to do that number by number all the way through the thing. But if you think of the mechanics of that, might you maybe take this number out, store it somewhere, and then one at a time, take this one, move it here, then this spot's empty, take this one, move it here, then that spot's empty. You see the thing, right? But still one has to get pulled out and stored somewhere. All right, so that's where we're going to start. We're going to call this one shift right is the name of what we're going to call it. Here in the main program body, let's accommodate for it by building the call to the function first. And kind of like what we did here, we're going to make a copy list. And I think I did a little bit of explanation on this, like why are you putting a list function around a list that's already a list? And the reason is, if I were to copy it directly, like is indicated here, what we're really doing is we're not making a copy of it. We're making a pointer in memory that points to the original version. So if I change this version of it, that one also changes, and that's not what we want. We want the original one to stay intact. All right, so we're going to take 110, which is our list up here, and we're going to listify it so it can go into a brand new list. Now we truly have a copy of the list. All right. So now that we've done that, we're going to call the function that we have not created yet. And this is kind of a backwards approach, right? So why are you calling a function you haven't created yet? Because I plan on calling it. I'm just putting the structure here in place to do it. Now, you notice that this is flagging it as an error, and it is because I have nothing there to draw from. And I am going to preemptively prepare to put that on the string or put that on the screen. And here I'm using the old approach as opposed to the F string or what we call string interpolation approach. And just to remember that you can do it either way. And I had this one pre-prepared, so I'm just using that one. We're going to come down here and define this function. And I think this is kind of interesting because when I do this same little technique, when I'm using Java, for example, something like this would in Java would flag red, give me an error message. But if I would hover over it, and I kind of hope, here it would do the same thing, but it just doesn't. But in like Eclipse, when I'm coding Java, it'll say, hey, you wrote a function that doesn't exist. Do you want us to create it for you? And it does it automatically. So I think that's kind of neat. That's not really an option here. And I've explored Spider a little bit. And if there is a way to do it, I'm not finding it. And you know what? I don't want to spend any time looking for it. Let's just type. Right, here we go. So we're going to define, this one's going to be called shift right. We're going to receive the data. And then we're going to start doing our maneuvers here. So kind of like we did last time, we're going to take the item that's in the last position and actually, remember we have this special syntax here, right? So if I do a -1, it's like going to the end of the list and back one numerically, which gives us the last item. So we're going to take that last item and pull it out. Now we're ready to start shifting things over one at a time. Now, if think about what I just said, that sounds like a repeating process because it is, so that it's going to go over and over again. So the syntax on that is for I in range, parentheses here, we're going to start with the last position. And of course, we can do this a few different ways. So one way is we can say, oh, not the whole word length. We can take the length of data and subtract 1 from it. Right? If you remember, you can also do the -1 thing, but we're just going to do it this way. Why am I doing this approach? Okay, so think about this. This needs a hard-coded number here, right? And if it doesn't know that spot, what does -1 mean to it? Okay, well, in principle, it would mean the end of the array, right? From the perspective of this approach, but that's not inside of square brackets, right? So I could basically, find a way to generate that value. This is probably the easiest way to do it. So that's why. All right. We're going to start at the end. We're going to move down to the first position, which is position 0. And we're going backwards. So I'm putting in a -1 in the last spot. All right. Then we'll do a colon here. And then we'll do the maneuvers. So every time we're in any given position, and we're starting, mind you, at the end of the list, not the beginning, we're going to find, the current position. So we'll start at the last one -1, right? Which puts us here. And then that position will take the item that's in the spot right before it, which I can refer to as data I -1. So whatever the current position is, look 1 to the left, grab that one and put it in this position. That's what we're doing. And you just do it over and over again. The whole list will shift over by 1. Then we'll come back out 1 indent level here, and then we'll take that first position, position 0, and we will drop in the last thing that we found, right? So the one that was in the last position now goes in the first position. All right, that's the function, right? So let's run it and see if it works. All right. So it says after shifting right. Okay, so the last number 10 came to the first position, and then everything else got shifted over. Pretty interesting, right? And we use a pretty small list here, but can you imagine it could do this on a list that was 1 million numbers long? You know, it totally could do that. Not sure why you would do that, but there must be some reason. All right, let's move on to the next piece. Um, all right, so the next one that we're working on is to replace all even elements with the number 0. So I'm going to come up to the main program body here, and I will be adding the next call, basically. So here's what we're going to do. And then once again, as we did with the previous one, we'll start by making a copy of the list, just in case it's changed, because you know what, it did change. And we'll call this one replace even. We're going to send the data in. Yeah, I know it's throwing an error, but we'll fix that. And then we'll do the print. Let's do the F string approach this time. And we'll say after replacing even elements, put in now we need to write the function. So we'll come down here, say F, and this one's called replace even. Send the data in and use our colon to get the function started. And I said dir, not def, so I got to fix that. And that's why the color coding is helpful. Otherwise, that's so easy to miss, right? All right, so then let's write the code for that. Now, think about what this would involve. We're going to look at each element, right? So we're going to just kind of walk through the list one at a time, and then we'll look at each number, load it up, see if it's an even number, and then if it is an even number, we're going to replace it with 0. Let's just go one at a time. How do you figure out if something's an even number? Well, you mod it by 2, and if there's no remainder, it's even. So that's going to be an if statement. But we need to loop through the whole structure as well. So this is going to be a for loop again. So we're going to do for I in range. We'll start at the first position. There's no reason not to. Up until the length of the data. And in this circumstance, you know, we're going to end at that point, you know, because that will take us up to that last element. And then we're going to check each time if the data in the current position, position I, if we mod that by 2, that's going to be equivalent to 0, right? If that's the case, then data in the current position is going to get set to 0, just like that. Now we have the setup to run it. So I'm going to go ahead and hit the run button on this. Error. And why am I getting an error? All right, let's see. Line 49. It's something in line 49 it did not like. I'm looking here. For I in range. So when I was checking the length of data, I used square brackets instead of parentheses. Really easy to miss that one. Didn't give me a direct error. And I think that's kind of interesting, actually. It didn't really give me an error, but it just shows you that you can put code in that syntactically is correct, but is not logically correct. All right, let's try that again. Because the length is a function, right? So if length is a function, you have parentheses after it, not square brackets. So here's the run. All right, so here's all the even numbers turned to 0. All right. Does the next exercise in here has this directive. Just drop this in. And that is to replace each element except the first and the last by the larger of its two neighbors. Now think about that. All right, so we're gonna start stepping through this list. We're ignoring the first and the last, but we'll go to the second one. And then we want to replace this with whichever number is larger, the 3 or the 1. So the 2 will become 3. Then we move over here, right? So now keep in mind, this is 3 now. And then which number is bigger, 3 or 4? 4, right? And it's going to kind of like perpetuate through the thing. So this is really kind of goofy little exercise, but hey, it is what it is. Here is my copy paste dump here, making a copy of the data. We're calling a function that doesn't exist yet, and then we're going to output the results. Oh, and you know what? Let's see, I'm copy pasting, and last time I used capital letters on that. No wonder it's flagging it. So there's the copy. Now we just need to create this function. You know what? I'm just going to copy that name as is, and I'm going to come down here, and I'm going to define that function. There's my colon, and now we'll write the code. Once again, this is a looping structure. So we're going to go for I in range, and we're going to go from 1 to the length of data minus, oops, I'm going to be inside those parentheses here, minus 1. So go into the last position. Then for each data location, as we traverse the structure, right? Now notice we are ignoring the first position, right? We're starting at this position, and then we take the length of data, which is going to be 10 in this case, subtract 1 to go to the 9th position. That's the mechanics. And then all we're going to do is just use, you know, the max function, and the max function can compare values. So you just put them in here, and you say, so the data in the position preceding this one, I minus 1, is the first thing we're comparing. And then the data in the position that follows this one, so I plus 1. We're just looking, comparing. We're going to swap it out with the largest. So here comes the run. Right? After replacing with neighbors. And what happens here, right, is everything just shifts down by 1. We're getting rid of 2, right? 1 and 10 stay in place. Right. That's the algorithm. That's what we're asked to do. All right. So that was replace neighbors. We have 2 more little things to do. So let's get to doing them. All right, so you see how long this program is getting. This is one of our longer ones so far. We're going to do another couple maneuvers here. So I'm making a little space to include this stuff. The next call is this one. Remove the middle element if the list length is odd, or the middle 2 elements if the length is even. All right, well, first of all, we have an issue here. I can't test it because I only have, you know, the scenario that I have a list that's even in length, right, with 10 things. So what I need to do is create another list. So what I'm going to do up here is, you know what, let's just copy all of this. And instead of calling it 1 to 10, let's call it 1 to 9. And let's get rid of that last element like that. So I got one even length one, one odd length one. So to test this one, I have to, do it against both of these. So all the maneuvers I make have to be doubled up here. First thing we'll do is I'm going to copies of the original lists. One for 1 through 10, and the other one for 1 through 2 copies, 2 different lists. Then we're going to create a function called remove middle. And each one of those is going to send data in. Now, what I didn't do here is I'm making a copy of that first list. And before I was just calling it data, but then when I copied the second list, I replaced it. So I better call these 2 separate things, data 1 and data 2. That's the unique function calls. Yeah, I do not have the function yet. We're about to create it, but I'm going to get my print statements in place so that when it's all built, all I have to do is hit run. Right. So if the list length is odd, remove the middle element. If the list length is even, remove the middle 2 elements, right? So on this list, we would remove 5. On this list, we would remove 5 and 6. So like, how do you do those mechanics, basically? Well, we're going to set up our function down here. Back to the margin. So we'll define it. We'll call this data on the inside, though. There's our colon. And then we'll start to build the code. Now, is there looping involved here? All right, this is kind of an interesting thought. I mean, that would kind of be one way to do it, right? You could find a way to loop through. But don't I need first to figure out just a way to remove the elements? And this is kind of going back to the Kahoot or lecture materials, if you will. But there's a couple different ways to remove stuff from a list. One is to do a remove, and then the other one is to do what we call a pop. I don't know if you guys remember this push and pop thing that we talked about, and like stack of dishes. Push, put stuff on top of the stack. Pop pulls it off. But pop can also pull stuff out of specific positions as well. So that's basically what we're doing. Now, I really actually don't need to do a loop on this because we're really targeting specific positions. So first of all, I can figure out what the length of the list is, and then based on that length, target a particular position for removal. Then the task will be accomplished. It'll be as simple as that. So I can do this with an if statement. So I can start with if the length of data, we're checking to see, let's see if the length is odd. Maybe that would be a good place to start. So instead of doing even, we would still do the mod by 2, right? And the difference is to check if something is odd, instead of the remainder being 0, like up here, this would check for even. We're going to see if the remainder is 1, which would indicate that it's odd. Kind of clever. All right. If it is an odd length list, then we're going to take that list. We are going to pop an item out. Which item are we popping out? Well, once again, we'll go back to the length of data. So we get like this value, right? And then instead of doing division, we would do floor division. I don't know if you guys recall this, but this is where you do division and the opposite of modulus, where you get in the remainder. Floor division just gives you how many times something goes into something without the remainder, right? So we'll just take the list, we'll floor division it by 2, and then if there's a remainder, it just ignores it. It found the middlemost position, and we're popping it from that spot. This is just the math for finding that middle spot. Right. If it's not odd in length, then it must be even. So we just do an else. And in that case, we need to pop middle two elements. And you know what? We can use the exact same formula here, not once, but twice, right? So it finds the middlemost, removes it, finds the next middlemost, removes that. And what's happened is when it's shifted, like if I pop this out, let's say, for example, 6 moves down, and then I just do the same maneuver because now 6 is in the same spot. I use the same math, right? I pop out 2 of them. Pretty clever, I think. All right, let's run this. Here's the run. Okay, after removing the middle elements from 1 through 10, remember, we would remove 2 from an even one, so 5 and 6 are gone. From the odd length one, we just remove 5 because it only goes up to 9. One last maneuver, and then this exercise is complete, and then we'll move on with our lives. Right. This task is to move all the even elements to the front, otherwise preserving the order of the elements. Okay, that's a little more kind of challenging if you start thinking about that, right? So we're looking at this list. So we're going to take 2, 4, 6, 8, 10, and then find a way to put those all at the front of the list, and then but still keep everything in order. Right? That's a kind of a tricky little maneuver. This is going to require slightly different mechanics, by the way. So let's begin by making a copy of the list again. So let's just call it data this time, and we will list 10. List. We're going to create a function called even to the front, or even to front. We're sending the data in, and then we'll have just a simple output statement here. Like this. Ready to run it. Well, ready to run when the function's ready. Now we still have to build the function, so let's do that. So this one's going to be called even to front with the data passed in. There's a colon at the end. And let's start building the code on this. All right, so let's think about how we might accomplish this. If we are wanting to do a maneuver like this, okay, so we would start with the number 1 and go, okay, well, it's not even, right? All right, next number 2, that's even. That should go to the front. So this would then go to position 0, and then where does 1 go? Well, 1 would be moved over. In order for me to keep track of this, here's what's going to have to happen. I'm going to have to keep track of which position I'm on, right? And then what position I'm evaluating. And that way, if the number happens to be even, then I can move it based upon the positions that I'm currently in. But you know what? We're going to have to keep track of 2 positions here. One for the number we might potentially move, and one for the number of the spot where it's going to go, right? So inside this function, I'm going to start by just setting up 2 variables. One to track our current position. I'm setting it to 0 because this list starts at position 0. And then one to track the even position, which we're also going to start looking at position 0. Keeping in mind, we put in a simple list of numbers that's in order from 1 to 10. We might not know what it is, right? So, all right. And then to loop through this, because this is kind of a repetitive process. Normally we've been going to for loops here, but in this case, it's going to make actually more sense to use a while loop, because we'll keep doing this until the position that we're looking at is less than the length of the data that we're sending it. Right? Now, on every iteration or every time through the loop, we're going to check the data in the current position. And we're going to have to increment this position each time through the loop, right? So we're going to look at the data in the current position, mod it by 2, see if it's even, right? So if the remainder is 0, it's even. And then we'll do the temporary storage spot approach. We're going to pull it out, put it in a temporary holding spot so we can move the other one around, right? And how are we going to do that? Well, we're actually going to take the data and pop it out of that current position. This is kind of interesting. So when you do pop, not only does it pull something out of a list, it knows what it's pulling out and I can store it somewhere. So we're popping it out, storing it temporarily. Then here on the next line, we're going to take and insert. And here's an example of putting something back into a list. And the way the insert command works is you declare which position you're putting it into. So we've tracked the even position, whatever that is. And then we're going to put into it whatever's in the temporary storage spot. And then we're going to increment our even position counter. So we're keeping track of 2 spots here, right? And if we find an even position, then we're going to increment by 1. So the first even number will go to position 0. The second one will get incremented to position 1, which is the second spot, etc. We do also, regardless of if a number is even or not, we will need to also increment the regular position by 1 each time we go through whether or not it's even. All right, that's all the code. All right, let's give this a run. Cross our fingers and hope it works. All right. So after moving even elements, so notice 2, 4, 6, 8, 10, all move to the front. 1, 3, 5, 7, 9, all to the back. All of them stay in order. Pretty clever little algorithm. This is kind of interesting stuff. And, you know, if you find like this kind of stuff fascinating, and most people do not, by the way, it's perfectly normal not to find it fascinating. But when you start looking at really kind of the logistics of what we're doing here, this is actually some pretty powerful stuff. If you guys ever go on to study a 4-year degree, especially like in computer science, where you take very specific classes that deal with these types of issues. And when I took a class like this, it was in my undergrad program, and the class was called data structures, right? And the whole course is about how data is organized, how it's structured, and the mechanisms we use to store it, manipulate it, move it. And one aspect of data structures is how do you sort stuff, you know? And here's an example really of a sort algorithm, which is discretely sorting even and odd numbers within the same structure. It's actually pretty sophisticated. You guys might not realize, but this is some pretty sophisticated conceptual stuff here. You know, and you can take this and you can scale it out. You could apply it to a significantly large list, right? If you wanted to. We're using a really small one. It wouldn't be that hard to now, because we know all the maneuvers work, to apply it to structures that are, you know, on a scale like of thousands of times larger, right? So, all right, that's exercise 6.4 in its entirety. What I'm going to do here for the sake of those watching the video here is I'm going to go ahead. This is all the code. So here's the up through line, let's say 35. Lines 35 through 64. Lines 64 through 95. Let's see if we get them all on there, but I'm trying. And the main function call at the bottom, which makes it all run. All right, this video will end here.